Alright, so we have the probability tree. This helps us to organize and visualize the different possible outcomes. It tells you when to add and multiply. You have different rules that govern probability. You have the addition rule, you have the multiplication rule, and you have the subtraction rule. Now, for example, you are given that the probability of an event happening is equal to R, which stands for the number of possible outcomes, and N, the sum of possible equal likely ways. What that means is that R stands for the number of favorable outcomes, and then N stands for the total number of outcomes. And then you are asked, what is the probability that this event is likely not to happen? Emphasis on not to happen. Now, when it's going to happen, we're talking about probability of E, but when it's not going to happen, we're talking about probability of E prime. E prime. And what that means is that you'll be subtracting the probability of that event happening from the whole 1. So whatever is given to you, once you subtract it from 1, that gives you the probability of that event not happening. Not happening. Invariably, that implies that adding the possibility of that event happening to the possibility of that event not happening should give you a sum of 1. It should give you a sum of 1. So we'll stop here for now, and then we'll go into answering other questions. Thank you. Alright, so we have the first question here. Find the probability of getting 3 on a rolling die. Now, when you talk about probability, there are certain situations that are commonly used. Number 1, the tossing of a coin, the rolling of a die, and then you have a pack of cards. So for this question is dealing with the rolling of a die. So find the probability of getting 3 on a rolling die. Now let's talk about the space sample of a die. Space sample S. Now, how many outcomes are we going to have in a die? If you're familiar with what a die is, it is that cube-like object used in playing a Ludo, right? So if you look very well on a die, you'll see that it is numbered 1, 2, 3, 4, 5, and 6. These are the possible outcomes that you can find on a die, and that's what we call the space sample. All right, so now the number of space sample is equal to 1, 2, 3, 4, 5, 6 is equal to 6. Now, in a die, how many 3 can we get when it is tossed once? How many 3 can we get? It is only 1 3. So, you write and say, number of getting 3 on a rolling die, I could decide to call that n of t for 3, is equal to 1. Now, probability of getting 3 on a rolling die, which is Pt, is going to be equal to the number of outcomes of getting a 3 over the total number of sample, right? So this is equal to 1 all over 6. So the probability of getting a 3 is equal to 1 over 6. Very simple. Once you can do this, I guess you'll be able to solve any question that comes your way.